I'm a technical coach. I teach minute-by-minute habits that software developers need to create good quality working software that lasts. These days, all the teams I meet are asking for advice and help with AI tools. So I'm teaching and coaching all the same code quality skills as before and how to achieve them with agentic AI. I find it helps to think in terms of not only augmented coding, but also harness engineering. So let me explain what that is and how it helps to ensure you can get good results with your AI tools. Hi, I'm Emily Bache. I'm a software developer, creator of Saman Coaching. Welcome to the Modern Software Engineering channel. If you enjoy the video today, please hit like, consider subscribing. We are lots of presenters here on the channel with a common goal to bring you great advice about the technical aspects of modern software engineering. I've talked before about programming being a set of many micro skills. I've got a previous video about that. Now we're still identifying all the detailed skills and behaviours that lead to effective use of agentic AI, but I have some good leads. The overall macro behaviour that I'm trying to teach and coach is working in small steps with plenty of opportunities to steer development that leads to high quality code being committed frequently to your repo. An important part of achieving that with agentic AI is having a harness. Birgitta Berkele has a great article about harness engineering and explains in a podcast that a good harness will contain both guides and sensors. So the harness's job is to constrain the AI to come up with good quality code and tests that do what you want. Now, you can, of course, just go on the internet and grab somebody else's guides and sensors, their harness. It's a pile of skills and hooks and scripts, a load of markdown files and command line tools. It seems to me a much better idea, though, to learn to make your own harness, particularly when you're just starting out with agentic AI, also so that you know what you've got and you can continually adapt it as your needs and your code base evolves. So today I'm going to start to explain about the kind of harness engineering that I've started to teach and coach. So everyone these days has got these AI tools in the IDE, but a lot of people are still using them just like fancy autocomplete. That's not really where it's at these days. In fact, I personally turn off that AI-generated line completion. It's just a huge distraction. If I'm writing some text by hand in my editor, I want to write it by hand. This AI tool will bombard me with suggestions that randomly flash into my field of view and distract me and demand attention and I switch it off. I'm not surprised a lot of developers think that AI is a waste of space if that's the only part they've ever tried. Agentic AI is different. It's a tool that you prompt that can itself use additional tools in a loop and iterate towards actually useful code. The suggestions it comes up with will at least compile, and often it's pretty good code. Now, as a technical coach, I have pretty high standards for my code, and the code that it comes up with by default may be kind of okay, but what I find exciting is that you can set things up so that the code quality is better than that, and it increases over time. With the harness engineering, you can set up a kind of flywheel, so it's always getting better. I'd like to pause here and thank our sponsors, Equal Experts, Transfic, Octopus Deploy. We're grateful for their support so that we can keep making these videos. And these are companies that we've chosen because they're relevant for people in software like we are. So please do check out their links in the show notes. As I mentioned before, an agentic harness can constrain what that agent does so that it will produce good quality code. And it's particularly useful in the typical situation of the teams that I'm coaching, where there's a lot of legacy code that's important to the business, but is difficult to work with safely. So in the past, I've got lots of experience of coming in to teach a team how to write good unit tests in this situation, improve the design in small steps. And I'm still doing that and finding that useful. But in addition, I'm helping teams to set up their AI harness as we go along so that their improvements will compound. Because the problem is, if you start with a lot of poorly designed code and tests, the agent will tend to copy the patterns that it sees in the code, and you'll just get more poorly designed code and tests. So instead, I want to try and set up this harness and this flywheel effect so that better code leads to a better harness and code that improves over time. So for the coaching, a good starting point is unit tests. We'll pick a test that could be better designed and improve it with help of the agentic AI. And it will probably take several rounds of prompting before the design looks any good. And often the team isn't really very good at recognizing good or bad unit test design. So we often have a lot of learning hours and general training in good design principles. So at some point, everyone on the team understands that we now have a good unit test design through prompting and iterating. And once we've got that example of good design style, we can start setting up the harness to help the agent to continue with that kind of design. It's a kind of unit test design guide. It's a knowledge document that the agent will use as part of its work. And it would just be a markdown file with something like, follow the arrange, act, assert structure, and probably more advice than that too. So when you're using the agent to design tests in the future, it will take this guide into account. So guide here is Birgitte Berkeler's term for a feed-forward part of the agentic harness. And most agents these days actually support this pretty well with a concept of skills. Now that is a kind of mechanism for the agent to automatically improve relevant guides into the LLM's context when you do particular tasks. It's pretty useful, but some of the teams I'm coaching have older agents that don't yet support this feature, and you can get the same effect by actually just including the relevant guide in your prompt. And that gives you more control actually as well. So guides give the LLM advice before it starts writing code, and it can refer to it during the agentic loop while it's revising and improving the code. But in some cases, it's better to instead use a sensor. Now that's another part of Birgitte Berkeler's language for the feedback part of the harness. So a sensor will give feedback after the agent has written the code. It will examine what's there and specify this needs improving. Often sensors are deterministic scripts, actually, that do the same thing every time. They might check the number of lines in a file to check it doesn't exceed a fixed limit, or find particular code smells that it can do deterministically. Some agents will have a hooks feature that would enable you to include sensors at the right point in the agentic loop automatically. But again, not everyone has those kinds of advanced agents yet, and you can produce a particularly similar effect by just including those scripts in your build step or your linter. So those are the two parts of the harness that I'm helping teams to build up for their code base. Every time we succeed with a design task, we update our guides and sensors to encourage the agent to continue to follow our preferences. So over time, it gets easier to prompt the agent and have it do good design because of that harness. And there will be more examples of good design in the code base that it will copy. So you start to get this flywheel effect that we're looking for, where the design is actually getting better over time. Now, this is huge. I mean, in legacy code, if the design is getting better over time, you're winning. You can put off that big risky rewrite and maybe even start to enjoy working with your code again. It's just so much better when developers can put the focus on understanding what the user needs and what exciting new features you're going to add, compared with what they often get, which is just trying to understand the existing design most of the time and having to fix a lot of bugs. Harness engineering, then, involves both adding, updating, and removing guides and sensors. What tends to happen is that this harness, these files just grow over time. We add more and more advice. And at the same time, the code base is improving, so less advice is needed because there's more examples to copy. And the models improve over time, so they don't need such a strong harness. So we need a way to balance this process so that we actually remove stuff from the harness as well when it's not helping. I recently read an article from Anthropic where they talked about the importance of getting the right information into your agents.md, which is a part of your harness. They outlined a process for evaluating the contents of that file. They would take previously completed tasks and have the agent do them again from scratch with and without the harness. and then they could compare the outcomes against that code that was originally accepted for that task to see what difference the harness had made. So this kind of evaluation was going to give really valuable advice about what should be in the harness. But it's actually kind of difficult to achieve in practice since you need a pretty large sample to work with to get any statistically relevant results. And it takes quite a lot of time and resources to do this analysis. So for a team just starting out with a new harness in your codebase, I think the most practical approach is just to have it be a normal part of every task to also update the harness, and encourage people not to be afraid to remove stuff. Big, long guides are expensive in tokens and they might not actually be helping. You can also do kind of spot checks where you take a branch and try the same prompt twice with and without a proposed harness update. But I'm not sure it's really practical for ordinary developers to do that kind of thing on every change. But fundamentally, I think developers need to own the harness for their codebase and treat it just like they would other important things like their shared build scripts or their manual tests. This is why I don't advise teams to just download someone else's harness and start using it. You won't know what's in it. You might be afraid to change it. I think it's better to set up something for yourselves that matches your team's preferences, that tailors the agent's general idea of good code for your situation. So if you'd like to find out more about harness engineering and the way I'm teaching it and how to make your own, I've got an upcoming online webinar about test-driven development with an agentic harness. You can sign up for free. There's a link in the show notes. Also, I can recommend joining the Patreon for this channel, or I've got a Patreon too, so that you can hear about all these kinds of things from there, as well as helping us to keep making these videos. In my work as a technical coach using the SAMAN method, I meet a lot of teams with difficult code and poor or missing unit tests. Agentic AI gives me real hope that ordinary developers can create this harness and this engineering flywheel where the design of the code gets better over time, not worse. And it's the same engineering principles, basically, that I've been teaching and coaching these many years. But now with the help of AI tools, a whole team can adopt this approach consistently on all their changes. That's the big vision. Happy coding.